Alright guys, on chapter 10 section 2 there was a couple problems that were asked and very good questions, because the first time I did it I missed it because I was failing to use the whole idea of n times p times 1 minus p has to be greater than or equal to 10. If we're looking at this problem to set up the null and alternative hypothesis, we can do that. 3%, that's what it's going to be equal to, our proportion. But then we have to determine by the context what's our alternative is going to be. That percent of mothers who smoke 21 cigarettes or more is less than 3% a day. So let's do a less than. But again, we cannot use maybe the calculations we were using earlier to do this. Before, we would just go to proportion stats, one sample with summary, and type in 2 out of the 115 up here, right? And use our hypothesized proportion of 0.03, and it would give us our p-value. But we cannot do this because n times p times 1 minus p is not greater than or equal to 10. So if we take our sample size of 115, right? So we have 115, n times p, 0.03 times 0.97, we get a number less than 10. So we cannot use the normal model. So what we have to use is the binomial model. In your book, it talks about this on page 444, if n times p times 1 minus p is not greater than 10. And it kind of shows some different steps. It uses the TI calculator, but I'm going to show you how to do it with StatCrunch. So, on StatCrunch, we have to use our binomial calculator. And we're going to put, the information they had. There was 115. The probability, the believed probability is 0.03. And they wanted to know that if it was less than, same way as our alternative hypothesis, 2. And now we get the probability of this happening. So we had 0.03, and it was looking at 2 of them smoked that amount. So what this stands for here is the probability of that happening based off of the information they've given us, 2 out of the 115. So that's a 0.326. A 0.326 is our p-value here. Great. And so that's different than if we used the normal calculator to do it. So from here, we know if we have a p-value that's high. If the p-value is low, the null got to go. But if it's higher than our alpha, then we would fail to reject. So when I fail to reject, we're saying it's not sufficient. So is there sufficient evidence to support the claim? No, there is not. So we're looking at A or C. The p-value is less than alpha. Now the p-value is greater than alpha. There is not sufficient evidence to conclude. So we'd be looking at choice C. So again, when n times p times 1 minus p is not greater than or equal to 10, we have to use our binomial calculator. I believe that should be something similar for 13. Looking at this one, here's that it equals 13.2 or 0.132, and they think it has increased since then. But when I use my calculator and I say my sample size of 60 times 0.132 times 1 minus 0.32, I get a number less than 10. Therefore, I have to use my binomial calculator. Here it was 60 was my sample size. I'm wanting to see if it's greater than, and then 15 of them. So 15, we said it was greater than. I'd be greater than or equal to would be good. And then my believe proportion was 13.2, so 132. And I hit compute, I get a 0.0098, which would round up to 3 decimal places to 0.010. And that should be my p-value, 0.010. Right? So I'm doing a greater than or equal to because we got 15, so 15 or more. And there's my probability. Again, since this one is less than an alpha of 0.05, I do have sufficient evidence, so yes, because the p-value is less than alpha. So, I hope this has helped. Again, we have to be cautious when we just get in the habit of doing, and I do the same thing, and just to go proportion, in StatCrunch, just to come over here and go stat, proportion stats, But if n times p times 1 minus p is not greater than or equal to 10, we cannot use that normal model to approximate. And so the other thing that we use would be the binomial to help us out with these p-values. So, have a good day. Let me know if you have any more questions.